Student, looks, there is a mistake. It is not 3, it is 2. Potassium hexacyanoferrate 2, because in 2 oxidation state we have calculated here plus 2. We write down in the common number 2 and iron. Up now write down there are 2 type of ligands, potassium and cyanide, and we know very well potassium, it is a positive ligand, it is a cationic form, and cyanide is a negative ligand. According to the rules of regulation, we have to write down the first of all, which thing is we have written here. We have written here naming the first negative ligand, then neutral ligand, then positive ligand. But if you are looking, it is a coordination sphere. This is a coordination sphere. It is a coordination number. Outside of a coordination sphere, if any ligand is there, then first of all we write down this thing, because these rules and regulation only apply and applicable inside of a coordination sphere. Outside of a coordination sphere, simply we write down the name without counting the number. Just like as potassium here, there are 4 atoms of potassium, but we don't calculate, we don't count, only we write down potassium. We don't write down tetrapotassium, only we write down potassium, because this potassium is outside of a coordination sphere. It is not inside of a coordination sphere. That's why directly we write down here potassium. Potassium, I didn't write down here the tetrapotassium. Simply I have written here potassium, because this potassium is outside of coordination sphere. Potassium. Now there are 2 ligands, potassium and cyanide, and potassium directly we have written because it is outside of coordination sphere. Now we are come to the coordination sphere, which is in coordination sphere there is only 1 type of a ligand, cyanide, and 1 is metal atom. Metal atom we have written the name here, oxidation state here. Now we write down, and all these rules are applied in this inside of a coordination sphere. If you are looking here, cyanide we have done in the second or third rule. If there is a negative ligand are there, we don't write down the complete name of this ligand. We write down only, we change the name. If cyanide is there, we write down cyano. If fluoride is there, we write down fluoro. That's why we will write down here cyano. If you are looking potassium, cyano, iron 2. Now numbering is 6. If you are looking here 6 cyanide here, then we write down here hexa for 6. Potassium hexacyano. Okay. Instead of iron we write down ferrate. Okay, instead of iron we will write down ferrate. Your name, IUPAC nomenclature of this complex is completed here. Potassium hexacyanoferrate 2, oxidation state is 2. Every time when we write down the IUPAC nomenclature of every complex, first of all find out in the first step, find out where is the central metal atom. Second step, we calculate the oxidation state of the central metal atom. The third step, write down the name of the metal at the corner of this line, where we have to write down the name of a complex. And after naming of a metal atom, we write down also the oxidation state. Then we start to write down, first you look where is a coordination number, where is the coordination sphere, and how many things are outside of a coordination sphere. If you are looking here, potassium is written here in the beginning and outside of a coordination sphere, but sometimes this K4 also written here at the last of the coordination sphere. Then at that condition, first of all we write down the name, and potassium we don't write down at the beginning, we write down hexacyanoferrate 2 potassium at that condition, if potassium has written at the last of the and or after the coordination sphere. Clear?